Thank you. Good morning and welcome to the 23rd annual exhibit of Hydrogen and Fuel Cell Technologies. We've been here for quite some time talking about the developments in this field. It's very important because there's a lot of things changing. We're all waiting for mobile applications. Mobile. Get the cards on the road. And one of the issues, of course, is how to get the fuel cells in mobile applications optimized and competitive with typical combustion automobiles. It's a difficult issue. We have a specialist on stage to talk about these specific issues for mobile applications. I'll be talking to Dr. Henrik Ljungcrantz, who's CEO and founder of Impact Coatings from Sweden, and we'll be discussing metal bipolar plate coating, presenting the new world-class coating equipment, the INLINECOATER. Please welcome with me Dr. Henrik Ljungcrantz. Good morning. I see you have something with you.
Yeah, it's a plate that we have been coating, so I will talk more about that. But in general, what we are doing is we do the coating. We develop the coating for the bipolar plates for the PEM fuel cells. And we also manufacture and supply the equipment, the machinery for doing this coating. So it's a turnkey solution. We provide the coating machines, the recipe, how to do the coating, the service, the consumables, and all know-how around that is needed to do high-volume production of these kind of coatings for the PEM fuel cells industry.
Let's start with how you got involved, how your company developed, when it was founded, and how you developed this technology. You had core competence in materials already when you started the company, so how did it all start?
We are actually now 20 years old. We are a spin-off from the Linköping University in Sweden. We started to look at how can we do coating cost efficiently. So we developed a deposition system. And in 2002, we started to do R&D on connectors, to coat connectors. How can we do the coatings for connectors more environmental friendly, lower cost, and also to have a longer lifetime? When we did that quite fast, we came in to look at the bipolar plate on the fuel cells, the PEM fuel cells. In that case, actually, this plate is a big connector. So the surface is connected to graphite or GDL, graphite mesh, and that is pressed to this side. And then you have these cells all the way up to somewhere around 300 to 500 cells for the automotive industry. So it is very important to have a good connector coatings on these plates. We have been doing that development from about 2002 to 2012 when we released our coatings. Since that, we have been working with other companies in order to optimize the deposition process and the material for the automotive industry. And we have been working with most of the car OEMs around the world to do that. And now we have a really, really good product. And we will say state of the art and the best in the world coating for these bipolar plates.
When I go back in history, I've been here for 15 years, and the initial stationary applications for PEM technology, they use graphite plates, which seems fine for stationary applications. Of course, as soon as you go mobile, you have vibration, you have issues of robustness and so on. The initial metal bipolar plates that I discussed on the stage, they were kind of lousy in performance. They did the mobility, they had the robustness for the mobility, but the performance was down. Have you been able to match performance with graphite technology? Have there been improvements in the overall efficiencies with your coatings for bipolar plates?
Yes. The important things to go to metal. First, I can say that the benefits to go for metals. The metals is you get a low weight. They are much thinner. So when you look at the whole stack, the size of the stack is smaller, and then it's also easier to produce in high volume. When you produce it in high volumes, you can produce this in seconds, and with the graphite it takes quite much longer time. So all that together, and also the graphite plates are fragile, it will break and so on. So everyone has been looking to use the metal bipolar plates, but you need a good coating on the surface on the bipolar plates, and that is the solution we provide. So with our good coating, we can use the bipolar plates in the automotive industry, and we can also be able to produce this in high volume to low cost. So this is affordable, and that is also very important, of course. If the fuel cell car will be too expensive to manufacture, we will not reach the tipping point where all the cars, or at least the majority of the cars in the future, will be fuel cell cars. So yeah, that's what we're doing.
I like the notion of the tipping point. I mean, theoretically, we're competing with combustion engines on two levels. One is the cost of fuel. We're working on that. The cost of hydrogen is dropping, and we do have targets of €5 per kilogram. The other issue, of course, is the cost of the PEM cell itself. And costs have many factors. It could be the durability issue, the robustness of the materials, how long does this PEM cell last, using expensive materials. Can you reduce the platinum? That's the catalyst side, and the other side, of course, is how expensive are the materials that you use to do the coating? Are they environmentally friendly, or are there other costs that appear? And stability, of course. So when we go through all of these issues, let's talk about the materials. Are there precious metals in the coatings you use? Is it an inexpensive material that you use?
No, there is no precious metal in our coating. It's a transition metal. We mix that with carbon and nitrogen, and we actually create a nanostructure. So it's a very thin coating, and the structure is made in such a way that we have a very good contact resistance, good conductivity, and also good corrosion resistance, which is needed because sometimes you get water and this kind of stuff on the surface, and it will start to corrode if you don't have a good corrosion resistance. And it's environmental friendly coating as well. So if you look at the life cycle of the material, it is very good. If you also look at the cost, we are, of course, always look at the cost. And when you look at the whole fuel cell stack, about somewhere around 1/3 to 1/4 of the whole fuel cell system, 1/4 to 1/3 of the cost is actually the bipolar plates. So to be able to make these bipolar plates in a low cost efficient way is very, very important. And about 1/3 to 1/4 of the cost of the plate is the coating. So of course the coating plays a very big role in the bipolar plate, and an environmental low cost coating. If we look at high volume production, if we have full production in our deposition system, we are in the range of, or at least lower than €0.50 per bipolar plates for the coating. And I would say that is the target that makes the bipolar plates so cheap to manufacture, that in the automotive industry can reach within a few years the cost target, so they can sell fuel cell cars for the same cost as the gasoline or the diesel cars cost today. Because in the end of the day, you have to be able to supply the new technology to the same cost as the old technology. Otherwise, you will not have the transfer to the new technology.
There are several technical issues that are involved in producing stacks. Bipolar plates play a fundamental role. Of course, the gold standard for conductivity is gold. So when we talk about issues of conductivity, where do you lie in that branch?
We used to call it, what is important is actually not the conductivity, it's actually contact resistance. Because if you line up this one and you have a high contact resistance between the DDL and the bipolar plates, then you will have losses. And that losses can actually be as much as 10 to 20% of the whole fuel cell. system. So of course, for all the car OEMs, it's very, very important to have a low contact resistance. So the lower contact resistance, the more efficient the fuel cell stack will be. And of course, later on, you will see tests between different car manufacturers. What is the fuel consumption? How efficient is the cell? So of course, this is one of the most crucial things for the car OEMs today. And when we looked at the performance on the contact resistance with our coatings compared to gold, we are actually as good as gold. We used to say that gold is end of the world, but we have actually sometimes even got better performance than gold, so we are beyond the end of the world. So yes, we have a very, very good coating, so as good as gold. Yeah.
When we were discussing this, the technical deals, again, they're important. This is a sandwich structure, the stack, and you have between them the gas diffusion layer. And when you have these going from one end to the other, the conductivity, the amount of resistance from one end of the stack to the other, and how it interacts with the gas diffusion layer is fundamental. So how are you at improving the entire function of the stack as it passes through the gas diffusion layer? What sort of performance advantages have you got?
I mean, we have looked at that. Of course, as I said, the interface between the gas diffusion layer and the coating is very important. If you have the gas diffusion layer pressed toward the metal bipolar plates, you will have hundreds of times higher contact resistance than we have. We have optimized the coating to the gas diffusion layer, and we have reached such a low value now that I would say we are state of the art. We are around 1 milliohm square centimeter, which is really, really good values in this sense.
And of course, you're here today to discuss it. There was a press release just yesterday. So the product is the new deposition system for bipolar plates. This is interesting technology. It's an export commodity. That is, you set these things up. What are the fundamentals of increasing production of bipolar plates? That is, I suppose you need to be able to scale up. We have a low demand, relatively speaking now. It is increasing day by day. It has to be able to be flexible to some extent. That is, whatever size of bipolar plate. And then there's, you mentioned this earlier as we were preparing, there are increasingly industry standards for various sizes for automotive applications. So in these terms, and we'll get to the turnkey application, of course, but I'm thinking of, is it a flexible system for coating? What sort of targets, sizes do you see for standardized manufacturing for automotive applications? And how do you deal with the different demands of different stack manufacturers?
Lots of questions. Let's see if I can remember all of them. We have developed a deposition system that is optimized for bipolar plates. So we have increased the productivity with somewhere between 3 to 5 times between our standard deposition units. So now we can manufacture somewhere around 1 to 2 million plates a year in one deposition system. That is approximately 3,000 to 5,000 cars per deposition system. And it's very nice scalability, because that is what quite often the first step that the customers is aiming at. And then if they want to add more capacity, they can just add more deposition system. We get the same performance in all our deposition systems, so you can just add one more all the time, and it's scalable. And for the plates, we see that it seems like the plate size now start to be standardized, almost standardized. Maybe it's because they use the same simulation program, or they get more and more experience. So the size today is around 350 to 400 millimeter in length of the bipolar plate, and the width used to be between 100 millimeter and 150 millimeter in width. So by that knowledge, we have designed this new deposition system, And we have also optimized the throughput. That is, we are evacuating faster. We are handling the movement inside the deposition system faster. We have also developed the new deposition sources that do faster deposition system, faster coatings, and then we have also optimized the sources, so we have a better utilization of the deposition material as well. So all that together, we in the new system that we are presenting here in our launch at this exhibition. We have a very, very good and strong tool that you can use for high volume production, but you can also use it for low volume when you do the test and sampling as well. And it's really easy to use. In general, you just put in the plates, you close the lid, and then you do the coating. Or you can add a robot, and the robot can load and unload the plates as well. So, and that is also a very beautiful thing, is that the footprint of the deposition system is small, so that makes it very easy to integrate into the production flow. So you just take the machine, put that into the production flow, and then you can automate the production. And you get a very robust process as well. That is another thing we also have been worked quite much with, is to get a very, very robust deposition process and a very robust machine, so we get the same results all the time and has almost zero scrap rate. And of course, going to high volume production, that is crucial. Otherwise, we will not be in this industry.
People used to make jokes 20 years ago when we started here. How many people does it take to operate a fuel cell? It takes one driver of a fuel cell car and 7 engineers with laptops. It's gotten a lot better, of course. But when people talk about things like deposition systems, it's very important to ask questions like, okay, so you export that system to a manufacturer. How long does it take after arrival before it sets up? Do you supply the support in order to get things operating? So how easy is it to integrate that system beginning with delivery to when it's actually operating?
Yeah. When we do an installation, normally it takes 2 days to do the installation, and so we are up running in general after 2 days. Then we do a training and learn the personnel that normally don't know anything about coating, don't know anything about our deposition system before, and it takes about 3 days. So after 1 week, they are up running, and then you can do a volume production after 3 days. Of course, we will always support them how to do the quality measurement and maintenance, and also how to do how to replace the consumables, and we also provide the service. Our personnel is doing the service, or we have a service partner that do the service locally, and we also have the machines are also connected over internet, so we can help our customer to monitor what is going on, and if they have any question, we can just go in and have a look and answer these questions as well. So these machines is really simple to use. Just put it into the production line and you're running. That's it.
For decades here, we've been waiting for mobile applications, the automotive and other transportation forms to sort of take on. We know that the explosion in growth is already coming. It started in Japan. Things seem to be picking up elsewhere. Where are your future market prospects? Where are you going to be going?
Yeah. I would say all over, but of course we see different stages. And right now, China is definitely the one driving the market. For the moment, we are in contact with about 30 possible customers, and they have planned to build up their own factories. So and in that, normally the volume is somewhere around 5,000 to 10,000 stacks a year. Of course, some has bigger plans for higher volumes, but that used to be the starting point. So we see due to the Chinese government and the pollution issues and the 5 years plan that they are working on now, where they are focusing on putting the fuel cell buses into operation and also logistic cars. It is a really, really big driving force for the Chinese companies to start the fuel cell business. So that is definitely one of the biggest markets for us today. However, we also see a trend that in a few years, or let's say that the car OEMs around the world, they have now started or is starting the next generation of the fuel cell cars. And most of them are now looking at to start with the development of the cars released around 2025. And the goal, what we hear in that direction, is that those cars should have the same price as a normal diesel or gasoline car have today. So that should be the tipping point where you should be able to buy the same kind of cars, but with a clean energy instead, and you should be able to run them and use them as you use the normal car today.
And you are a publicly traded company, so it's time to invest. Okay. This has been a fascinating talk. This is an important development, of course, because the automotive sector has over-announced what they've been able to deliver going back to 2004, but we're finally there. We're very close to this tipping point, and one can see it coming in the next few years. It's a thrill to have you here this year. We hope you come back next year and tell us about how things have been going and how things have been developing. So I've been talking to Dr. Henrik Ljungcrantz, who's CEO and founder of Impact Coatings. Their booth is C52. More information and the conversation should continue there, of course, but you can find that at the booth C52 in that direction. It's been a pleasure. Thank you, Henrik.
Thank you very much.